Okay, great. All right, thanks everyone, and thanks for the introduction. And hey, how are you? And thank you for the invitation. So I'm just going to talk a little bit about the types of programming that we do through Illinois-Indiana Sea Grant. Talk about Illinois-Indiana Sea Grant kind of overall, but then also talk a little bit more about my program, and just to give you guys an idea of the type of stuff that we do. All right, so Sea Grant's mission is to enhance the use and the conservation of coastal, marine, and Great Lakes ecosystems. And they want to create a strong and resilient economy and a healthy environment, and also resilient and inclusive communities. So Sea Grant is basically, it's a partnership between the federal government through NOAA and universities. So there are 34 programs nationwide. Every state that has a bit of coastline, either on a marine system or in the Great Lakes, they have Sea Grant offices, and it's usually between, again, NOAA and then the land grant universities in those lakes, in those states typically. So in Illinois, Indiana, it's a partnership between the University of Illinois down Champaign-Urbana and Purdue University and NOAA. So the directorship, the administration of Illinois-Indiana Sea Grant right now is at Purdue, and it can switch back and forth depending on just how things are working at a specific university. But we also have people sort of spread out in different areas, people who are up closer to the lake. So we have a lot of staff that are down in Urbana and Champaign and also West Lafayette, but then there's people like me who are up in Chicago. So I live in Des Plaines, just down the road. We have people at the Botanical Gardens in Glencoe, people in Hammond. This is an older map. We actually have a couple of new hires that are in new places, and it might be people who are of interest to this group. We just hired 2 new coastal resiliency specialists, and one of them is up in Waukegan at the Illinois Department of Natural Resources Lake Michigan Biological Station, and another one of them is in Indiana, in Chesterton, Indiana, right by the Indiana Dunes National Lakeshore. So that's sort of how we're spread out. So Illinois-Indiana Sea Grant, we wanted to create, maintain healthy ecosystems and the economies of the southern Lake Michigan basin. That's like where our big emphasis is, because that's where our coastline is. And we do this through, essentially 3 means. We have research, education, and then outreach. So we partner with a lot of organizations, and we do this, we partner with different institutions, agencies, all sorts of people. We do this to try to sort of magnify our effect and increase our ability to sort of make an impact. We have a number of what we would call specialists, people who work in different areas. They work in these 4 different areas. So there's healthy coastal ecosystems, which that's my focus area, and I work in like Great Lakes monitoring. But we also have people who are doing green infrastructure work, working in resilient communities. We have a big emphasis on education, so we have people who are developing curriculum for elementary schools and high schools based on aquatic sciences. And then we also have people who are doing safe and sustainable seafood, so people who actually work with like aquaculture growers in all throughout the state. So it's a pretty broad area that we're working in. One thing I wanted to make sure that I emphasize with this group is we are a funding agency. So we have, for the faculty and for people interested in writing the grants, we have competitions that run sort of as we have money available, but it's usually every year or 2. We'll have what we call our bigger competitions, which are, it's typically between $10,000 and $200,000 a year, and our projects tend to run 1 or 2 years in duration. So be on the lookout for that. We also have a web page or a listserv that you can sign up to get all of the updates. So we have the big research funding grants. We also have, for faculty, we have Illinois-Indiana Sea Grant Scholar competitions. So those are for like a 1-year project where we give faculty like $10,000. We also connect them with some of our specialists so they can help them develop communication, outreach, and extension based on their research program. We also run fellowships. One of the more prestigious fellowships that we help with is the John Knaus Fellowship, Marine Fellowships. Those are open to any graduate students in the state of Illinois and Indiana, so Northwestern students are encouraged to apply. In the Knaus Fellowships, it's you're paid to go to Washington, D.C. for 1 year, and then there's this process where they match you up with different people, so you'll have a host either working in the legislative or the executive branches. So you might be working for as a science aide for a congressperson, or you might be, helping set policy in NOAA marine fisheries, things like that. The other thing I'll say about these Knaus fellowships, if you're interested in policy, these people tend to stay in DC a lot. Like they end up making a career out of doing policy. Not necessarily all the time, but
Chris,
yeah.
ask for a clarifying question. Is there a time in your PhD career when you can apply for it, or when you have this few months?
It's typically later in the, as you're sort of finishing up, because there's, in all honesty, they're very active, and there's not, if you're writing still, you might want to almost be done writing, because you're going to be your yearly calendar is going to be very full while you're there. They're very busy while they're in DC. But a lot of people, I know people who have gone and come back. I know several people who went and just stayed. So for grad students, we also have Illinois Indiana Sea Grant Scholar competitions as well, sort of the same thing as for the faculty, where if you have a dissertation or a thesis that you want to develop some communication, outreach, and extension for, you can apply for these as well. So I'm just going to throw this up here, just so if you guys wanted to, the contact information for the people who run the research program and the fellowships, and then the web pages where this information is. Again, and if you want to, I could take people's names, email addresses down. We can put you on the email list if you want to find out about the funding. Okay, so now I'm going to sort of shift and talk a little bit about what I do, so you guys get an idea about kind of the things that Sea Grant are busy with. So as I mentioned before, I'm in the science and monitoring program. I'm Healthy Coastal Ecosystems Science and Monitoring. I'm the Great Lakes Ecosystem Specialist for Illinois Indiana Sea Grant. So as part of that position, so my main responsibility is I'm a liaison between Sea Grant, Purdue University, and the EPA's Great Lakes National Program Office. So they're here in Chicago. And they are the group that is responsible for monitoring water quality conditions and biological conditions in the Great Lakes. They have a 140-foot research vessel, the RV Lake Guardian, and they do a lot of work monitoring biology, water quality, and I'm going to talk a little bit about hypoxia, actually. So I work with this group. The little sort of arrow-y diagram up there is just basically my main responsibility is to provide data access for people. So I want to make sure that all the scientists working in the Great Lakes region know about the GlenPO monitoring programs, know that they have access to this data. It's publicly available data. But I also sort of have my own little applied research program where I'm trying to help them to basically improve their monitoring as they go. They have all these long-term programs that they've been doing forever. I'm here to help them kind of maybe adapt a new technology towards it or something like that. So one of the things, I'm just going to one of the things that I've been working on for a long time now is hypoxia. And so I'm just going to run through this little quick cartoon so we can talk about how hypoxia forms in lakes. This might be stuff that you guys already know, but I just find it better to start there. So hypoxia it's a problem in all ecosystems basically, but it's becoming increasingly obvious that it's a problem in freshwater ecosystems. Hypoxia starts basically during like stratification. So in the spring, you more increased temperature. You have increases in the surface waters. That creates a density gradient, which makes a stratified condition. So if you guys have ever gone swimming in a lake and you go down real deep and you feel it get cold all of a sudden, like that's because these are two different, because of density, the density differences in these two different layers. There's two layers there. There's the warmer surface water, cold bottom water. Early in the season, the oxygen dynamics between these two layers are about the same. But then sort of as the season goes, you have longer periods of stratification. One thing that increases the prevalence of hypoxia is when you have a lot of nutrients coming into a system. What you have here then is you can have these increases in nutrients can cause algal blooms, which they're photosynthesizing in the upper layer, creating oxygen for the upper layer. But ultimately, they'll die, they'll go down to the bottom, they start decomposing, and that's when they start using up oxygen in the bottom layer. And then because of these density differences, that top layer is totally isolated from the bottom layer. So you can use up all the oxygen in the bottom. So that's how hypoxia forms. This is really common in a lot of different aquatic systems. One place where it's very prevalent is in Lake Erie. And Lake Erie is just kind of known as this problem, that have this problem with hypoxia. And it's basically because it's like perfectly formed to experience hypoxia. So Lake Erie is the southernmost, it's the shallowest, and it's the most productive of all the Great Lakes. And then if you look at this sort of side diagram, that's like if you're looking sideways. The central basin of Lake Erie, so that big basin in the middle, it's basically formed perfectly to become hypoxic. It's deep enough to stratify, but then that bottom layer is really thin. Like it's not like halfway through. It's like there might be only like 2 meters of the bottom layer. It's a really productive system, so there's a lot of biological activity down there, and it just basically uses up all of the oxygen. So we know Lake Erie, it gets hypoxic almost every year. It probably has even before humans were really messing with it. Like it's just there, perfectly set up for hypoxia. But we do know that human activity can make it worse. So the EPA's program has been monitoring dissolved oxygen going back to the 1980s. They started looking at dissolved oxygen in Lake Erie. And so for their monitoring program, since the 1980s, they take that big research vessel out, they go to Lake Erie, they go from Milwaukee to Lake Erie, and then they hit 10 stations, they put down these sensors, and they measure the oxygen concentration in the water column. At 10 of those stations, they do it about every other week through the stratified period, and then so you can get a lot of information doing this. So this is like the type of information that they generate. You can look at how oxygen depletes through the season. So here we have day on the x-axis, dissolved oxygen concentration in the bottom water on the y. Each of these dots is one of those sampling trips, and it's the average of the oxygen concentration in the bottom water. They're coded by year. So what you can tell here is these sort of browns go together. That's 2014. It was a really cold year. There wasn't a lot of stratification. It was a really mild hypoxia year. So at the end of the year, dissolved oxygen concentrations are still relatively high. That's compared to like 2012, where we have down here, dissolved oxygen concentrations basically at 0 at the end of the curve. So you can look at like interannual variability in dissolved oxygen and the severity of hypoxia through time using these methods. But we're also interested in knowing, more. So we started reaching out, talking to different groups. One thing we did was we knew that these fisheries managers are going out there, they're spending a lot of time on the water, and they're putting a lot of equipment out into the lake. there's a program called the Great Lakes Acoustic Telemetry Observing System. This is a group of fisheries managers that go out and they put acoustic tags into fish, so tags that are giving off sounds, and then they put these acoustic receivers out all over the lake, like all over the place. This picture, the thing that looks like a bottle at the top, that's an acoustic receiver. So that's there to like hear the pings of the fish that are going by. So we partnered with them and we got them to start putting optical dissolved oxygen sensors on these moorings. So that's what the arrow is pointing to, like artfully duct taped to the release. But we can greatly increase the spatial scale and the temporal scale of the stuff that we're doing now. So just thinking about the temporal scale, so if you remember the one map I showed where we got 10 stations, now all those white dots are dissolved oxygen loggers. So we have 45 stations, and now instead of just measuring dissolved oxygen in the middle of the lake, we're all over the place in 5 meters of water, 22 meters of water. So we can increase the spatial scale. We can also increase the temporal scale dramatically. So these dissolved oxygen loggers are taking a reading every 10 minutes. And so and they're out there all season. So we can actually look at the daily, the hourly, by 10 minute dissolved oxygen concentrations in the lake. So we get more of a continuous measurement of hypoxia during the stratified period. And that's like at the end, you can see like this graph, like hypoxia increases and then it drops off. Like that's what happens when there's the fall turnover, when the lake cools enough that those two layers sort of separate. So then the oxygen sort of comes back everywhere. So we can also learn, what we've learned is that this also a very dynamic system. Like hypoxia, it's not just this sort of tub that's filling with hypoxic water. It actually moves around and stuff. So let's see, does this work? Okay, yeah, all right. So this is gonna be a movie where we're looking at, this is the interpolation of the dissolved oxygen concentrations on the bottom. So we're starting in mid-June, and what we found is that hypoxia sort of starts down here in this like southeast sort of corner, and then through July it sort of gets worse. As it gets more red, that's when it's getting worse. And then by August, you start to see really severe hypoxia kind of everywhere. And then you have, like, it sort of peaks out in August, and in September it starts to shrink because the lake's cooling. And then you have the turnover that happens where it just rapidly just sort of goes away. So it's a really dynamic system. It's something that like we didn't really expect to see how much this is like sort of moving around. And then I'll just like kind of end with why we care. Hypoxia, like we know it has impacts on invasive species. This is some of the other work that I've done that we could talk about at some other time. Quagga mussels are a big problem in the Great Lakes. They're not in central Lake Erie, and it's because of that hypoxia. So I'm not saying that's good, that's bad, whatever, but it does have a direct impact on nutrient cycling. If we get rid of hypoxia, we're gonna have mussels there the next day. So what would that do to Lake Erie? We're not sure. It also has impacts on ecosystem services. That dynamic hypoxia, it can move into water intake cribs, and it can actually have an effect on the fouling of drinking water. We also know that fish really respond. I mean, that makes sense, right? They respond to oxygen. So they avoid the hypoxic areas. They tend to concentrate on the edges, like right where there's just enough oxygen for them. So that has an effect on the efficiency of how fish are caught, either through like population assessment surveys by fisheries management agencies, but it also has the effect of actually increasing catches of commercial fish. Like the commercial anglers know where that hypoxic edge is, and they'll set their nets and they'll increase catches. So that has an effect on the fisheries management in the system. And with that, I say just thank you, and I'll take any questions.